Triangles that have all three sides, this was the second case where we couldn't use the sine law. So I'm going to show you guys today how to use the cosine law, show or review how to use the cosine law to find angles. I'm going to give you guys two methods. Most of you will pick the second method, okay? So let's dive in here. So we have, in this first example, we have three towns connected together, three side lengths, three distances, 10 kilometers, 15 kilometers, and Brookside and High Cliff are 16.5 kilometers apart. And we are looking for the angle between the new road and the existing road from Rolling Meadows to Brookside, which would be this angle tucked in here. We're trying to find the angle at Brookside. So essentially, if you just relabel the triangle with the letters of the town, R, B, and H, we're essentially finding angle B. So how can we use the cosine law to do this? So because we are finding the value of angle B, we are going to want to use the version of the cosine law that has B squared on the left, because then cosine B will appear on the right. Can you guys take a second? What would the cosine law look like for that triangle, at least the way we set up yesterday, if we're have B squared on the left? So how do all the other letters R and H match up? I'll have a sip of coffee and wait 10 seconds while you do that. All right, here I come along for the ride. Do one of you guys have it? That's okay. Might just be one of those days. I'm used to people, my calculus class has 13 people in it, so I'm used to people not talking to me during a lesson. R squared plus H squared minus 2 times R times H times the cosine of angle B is how we would set it up. If you think about it, in this equation here, we know B, or we know side B, side R, and side H. The only thing we don't know is cosine B, so we can solve for it. So that's what we're going to do. This first method, we're going to plug in all we know, and then we're going to solve for cosine B afterwards. So here we go. Side B, 15 squared. Side R, 16.5 squared. Side H, 10 squared. Minus 2 times 16.5. We're just plugging in our stuff. But this time, the only thing we don't know is cosine B. You guys have all learned about solving equations, whatever course you took last year. So we can solve this equation for cosine B and then get the angle. But if you're doing it this way, I'll give you some tips, because some of you would be tempted to don't mark down what I'm doing here. Some of you will be tempted to do all of these operations in a row and then multiply them by cos B, but that would violate order of operations. We got to do 15 squared. We got to do 16.5 squared and 10 squared. We can add those together, but the 2 times 16.5 times 10 is being multiplied with cosine B. So we got to make sure we keep that separate. So this is just my fatherly advice after doing literally hundreds, maybe thousands of cosine law questions in the past. 15 squared is 225. Let's do 16.5 squared and 10 squared all at once. No need to round here. So that's 372.25. And then we have minus. And then let's do 2 times 16.5 times 10. I think that's 330 times cosine B. Again, you have to be careful here. We can't subtract 372.25 and 330. The 330 is being multiplied by cosine B. We got to collect the like terms. We're going to move 372.5 to the left and subtract it. So 225 minus 372.25. What do we get? Minus 372.25. Minus 147.25. We're almost there, because now we can get cosine B by itself. by dividing both sides by negative 330. So I'll write that this way. To get cosine b by itself, we just use division. Okay, now we're pretty much done. Let's do that division, get the decimal, and then we can use inverse cosine to get angle B. So this method works. It just relies heavily on your solving equation skills and your numeracy skills to make sure that you don't multiply some things together that shouldn't be multiplied, but it's manageable. And then shift cosine. About 63.5 degrees. Did you guys get about that as well? 63.5? Okay. So you can, if you want to, plug in all the numbers first and then rearrange. I don't know anybody that actually likes doing that. It's a pain in the butt because every single time you want to find a side, you've got to plug stuff in, you got to do some calculator work, you got to rearrange. It's a lot of work. The alternative is to see if we can find an alternate version of the cosine law that helps us find angles that we can just use and plug and play, and it gives us our answer in a more direct manner. So that's how we'll do the next one. So in the next example, same scenario, 3 sides, no side angle pair, and we want the angle between the first and second leg in our diagram. That is angle B again. So we're going to do this one a bit differently. So let's write the cosine law for side B because we want to get angle B. So B squared equals A squared plus CE squared. Almost wrote a B there. Of course, you guys would have told me if I made a mistake. All right. And what we're going to do is we're going to rearrange first and get a new version of the cosine law, a new formula. Well, not a new formula, just something that makes our lives a bit easier. To do that, I'm going to do a little bit of massaging, a little bit of rearranging here. Let's take that 2AC cos B term. Let's move it to the left, and we'll make it positive. So we have 2 times A times C times the cosine of B. On the left, it's positive. Now let's move B squared to the right. A squared and C squared are still there, and then B squared, we'd have to subtract it off. We can now get cosine B by itself pretty quickly by just dividing both sides by, that's a terrible line, by dividing both sides by 2AC. And what we have is a nice, tidy formula that helps us find, if not B directly, it helps us find the cosine of B directly. We've done all the rearranging first, and now it's just plug and play. And who doesn't like just to plug into a formula and do the calculator work? This is the alternative method, and it's the method I'll be using moving forward. And you guys, I will, just like I will always give you guys the cosine law for sides, I usually give you guys the rearranged version too. So now that we've done the heavy lifting up front, now let's just plug stuff in. Side A, 2.4 squared. Maybe even, since I have the space here, I might just label my sides A, C, and B there. Side C plus 3.8 squared. Subtracting side B, which is also 3.8 squared. All divided by 2 times the product of A and C, which was 2.4 times 3.8. Yes, it's a beefy little calculation for us to do, but it's manageable. Now, I'm not your dad, so do what you want. My advice here would be do the top and then do the bottom separately. That's just my advice. If you're really good with brackets on your calculator, then you can do this all at once. But yeah, I usually do it this way. So the cosine of B is equal to, I got 5.76 on the top, on the bottom, $18.24, and then we Divide those and get the decimal. .3158 if we round correctly. Yep, and then inverse cosine gets us the angle. And I got about 71.6 degrees. So as you do more and more of these, if you find an opportunity to shave off a step or two, fantastic. You get better doing more than one thing on your calculator at once, fantastic. But just do what you need to do to be comfortable. But moving forward, I'm just going to be using my rearranged cosine law formula because then it's just plug and play. And that's it. That's the new thing for today, if you want to call it new. For the people that took 2P last year, we haven't found angles with the cosine law yet. That's how we do it. For the 2D people, hopefully you've been refreshed. Now, here's a little exercise. Now, let's not actually find the angle here, but just getting practice setting them up. And I've realized we actually already did an example finding cosine B. So let's mix things up a little bit. Apologies if you've already done it. But can you guys write out what would the cosine law formula solving for cosine A look like with this arrangement of letters? Use the same structure as before. If we found the cosine of B, where did the B squared happen? We subtracted the B squared. And everything else was A and C. And you use the same pattern and set up the cosine law for angle A in this one. And then angle R in the next one. We don't want to get too redundant today because it's kind of the same thing over and over again. We don't need to do 10 examples of using the same formula. But let's at least get a couple done, at least setting up where everything would be plugged in. Does any brave soul want to volunteer setting up the cosine law here for the cosine of A? So if I was Miss Warner, I'd pick on somebody and just make them do it. But I'm not Miss Warner. Don't do that. No? You guys going to make me do it? Okay, so if you're finding cosine A, it's the other two letters squared and added together. And if you're finding angle A, you would subtract A squared. On the bottom, it's always 2 times the product of those other two side lengths. Okay? So if we're finding cosine R, maybe now somebody's more confident. If you're finding cosine R in triangle PQR, it would always be the other two sides, the other two letters, P squared and Q squared. You would subtract the R squared. And on the bottom, always 2 times the other two letters. Good job, Andrew. All right, you guys okay with that? It's the same setup every time. You're subtracting the letter that matches the angle. Okay, so let's do one more. We're going to solve a triangle completely. Note we have choice now. This triangle, we have all 3 sides. It doesn't matter which angle you find first. Now, because I've set my table up in the bottom, TUV, why don't we go in alphabetical order? That will ensure that, at least for our lesson, we all get the same values. Now, in the wild, if you and your C partners were solving this triangle, and one of you found angle T, and one of you found angle U, and one of you found angle V, when we find the other angles, we should all still match up. But let's find angle T. Now let's actually, let me improvise here. Let's talk about a strategy first, and then you guys can move forward on your own. So we have choice, but we don't get bogged down by choice. We just make a decision and go with it. Find angle T. And to do that, you have to use the cosine law. We don't have a choice about the law we use here. We have to use cosine law for angles. But you could pick T or U or V. We'll do T. Secondly, now that you have one angle, we have a side angle pair, right? We don't have to use the cosine law anymore. We could find angle U and we could use the sine law. Lastly, once you guys have 3 angles, you can find angle V, and I'll just tuck in brackets here, just the fact that angles add to 180. Can we just have a team talk? If you really love using the cosine law for angles, you could just find all 3 angles using the cosine law 3 times. That'd be totally fine. Totally correct. Maybe a bit inefficient, but it wouldn't be wrong. So I'm going to leave it with you guys. Can you find angle T? Check with your C partners or your imaginary C partner, since many people are gone today. Find angle T first using the cosine law. Set it up, give it a spin. Then we'll find angle U using the fact we have a side angle pair, and then we'll find angle V last. I'll pause the recording. You people at home can try this as well, and I'll come along for the ride in a few minutes. All right, we are unpaused, and I'm going to help you set up the cosine law for T. Other 2 letters, squared added together, subtract side T over 2 times U times V. T, U, V. So what's that? 5 squared plus 7 squared minus 6 squared all over 2 times 5 times 7. If you plug things in right away, that's no problem at all. How are the mental math skills today? The top would be 38. The bottom would be 70. Yep. Which as a decimal, 0.5429, which gives us an angle for T. I'm going to keep 1 degree of accuracy in my angles here. Shift cosine. 57.1 degrees. How'd I do, everybody? Did we get that? All right, perfect. 57.1 degrees. I'll even add this to my diagram. Hey, if you are feeling like you would like more cosine law practice and want to find angle U using the cosine law, be my guest. However, I am going to use our side angle pair to do that. I think it's just a little bit more efficient to use the sine law. I'm going to pass around actually the assignment. People are finished, so they can get going. Before I pause the recording, though, this is especially for our 3U students. Note that this triangle is a very, very clearly an acute triangle, so we don't have to think about the issue we have with the obtuse angles in that alternative case of the sign being positive. Everything's acute. We can just pretend we're in grade 10 and go about our business. I do have a question that deals with that in this assignment, though, from 3 people. So, pause the recording. I'll finish this off in a second. All right, we're wrapping things up here. 5 sine 57.1 divided by 6. So as I wrap up, minor talking point. Let's say you worked ahead and did this question and used 57. You will have a tiny difference in your answer than mine. That's okay. I'm a process guy. But I got 44.4. And then we don't need to do any crazy work for V. We just take 180 and subtract our other 2 angles. Life is good. The mental math is not happening, though. 180 minus 44.4 minus 57.1. 78.5 degrees. So we should all agree, if you did some extra rounding here or there, we should only be off by a teeny tiny bit. All right, anything you guys want to chat about? The 3M people, that was new for you guys, finding angles, but it's just rearranging our cosine law formula. All right, we'll end the video.